Hello, mentors. Welcome to meeting 5, judgments. And so this will be February 15th. And there's two parts. The first one is called choices. Let's choose occupations for some people and then count how many total options we have. So as you can predict, this is a counting activity. And then after the break, we will be doing an Othello tournament. So it's a minute to learn, a lifetime to master. It's a very fun abstract game, similar to chess, but simpler. Let's play this board game in pairs and also in teams. So there's going to be a tournament led by your leaders in a way, depending on the room size and students. But you will also, of course, monitor and help all around. Let's look at the overview in a little more detail. So in this meeting, we'll analyze stereotypes. So it's going to be all about stereotypes through basic combinatorics, counting permutations in the form of field tables and using trees, addition and multiplication expressions, and also time strips. So students will be detecting their own implicit biases and also stereotypes from others. And let me say one thing that is important next week. So in meeting 6, the week after, you will go back to stereotypes by solving a logic puzzle. So kind of try to leave the discussion open. You will return to it the week after. And so it's going to be like a follow-up in that sense. So choices, the first part, students answer combinatorial questions about options for filling a table. And there are going to be implicit biases regarding gender and occupations. So we'll practice 2.2 in the framework, show it in various ways, and also pay attention, of course, to engaging all students. Let's speak a little bit about show it in various ways in a second. After this, we'll play the Othello tournament, and we'll learn the abstract game of Othello, play a tournament, and reflect on the most successful strategies. So the idea is to have, of course, a lot of fun, but to also extract some mathematical learning or strategies from this tournament. So have students talk mathematically about the game. The first part is 40 minutes, and the second is also expected 40 minutes or so. So it's kind of a balanced meeting. And some time management tips. In part 1, you may skip question C, depending on if you have time, which is a challenge. Of course, if you have time, go for it for sure, but you can leave it as a take-home otherwise. And then for part 2, you can streamline some gameplay in this Othello game if it's taking too long to play. Do it along with your LAs and tell them a little bit about that. So the idea, of course, especially if you have large tables, so it's going to be important to take a look at that in detail. So how this framework look? Show it in various ways, 2.2. So remember these 9 components. So far, we've covered a lot. And this is all about show it in very ways means that both mentors and students, so not just the mentors, but also the students, take ownership on representations in math. So represent mathematical ideas in more than one way, also relate them to each other with explicit connections. So maybe writing on the whiteboard or saying some things about how this representation relates to this other representation that another student made, for example. Also means to identify which ways are most effective. So some are better than others, of course, but it's not just using that most powerful, but kind of like a story or like a progression. So you may start with some representation or way to represent things that is not as effective and then kind of move on to more effective ways. And so here are some good habits that you can, of course, read on your own to prepare for that. And of course, in coaching, you can also practice these habits. So this is 2.2, showing multiple ways. Of course, this is not new to us, but we'll practice it a lot more during coaching and also homework. You can read a little bit about that. Let's go to part 1 now, choices, and take a quick look. So there's a video on these counting problems, but essentially going to the workbook, there's going to be a game first, a quick game. And it should be very quick because we're trying to catch stereotypes from students. So for example, they could say that the programmer, maybe they could just say that, of course, it has to be a guy, like a stereotype, which of course it's not necessarily true, but it may reflect a stereotype. Another would be if you stay at home, you have to be maybe, female, things like that, preschool teacher, plane pilot, mathematician. So they're feeling this quick, almost without thinking. But so, because if you give them many time, then, we won't be able to detect these implicit biases, but of course, give them just a little time so that, hopefully we can catch some biases from this student. And then there's going to be a quick game. It's kind of like a random game just to hook students. So 20 points for each peer that fill their table exactly as yours. So they start comparing tables and see how they match. 10 points for each peer whose table is just one switch away from your table. And so they start to, to understand how these tables work, which will be key to what follows, because what follows will be completing this table and analyzing how many ways or different worlds they have to complete. So these are the scorings, and then these are the problems here in the bottom part. So now they'll reflect mathematically, okay, how many different field tables can we create? So if I were to write all the tables in the world, of course, with the property that you cannot repeat these occupations in this table, how many do they have? The next question, if we add a new person and a new occupation to the table, how many different ways are possible now? And this is really interesting because some students may just repeat the problem without thinking about connections to what they did, or other may start thinking about connections, which is a very powerful feature of counting. This, recursiveness, in the sense that you solve a small or simple problem, and then that can help you to solve a slightly more complicated problem. Part C is a challenge because you're now adding not a new person, so it's more challenging, but a new column. So instead of just having occupation, you would add a hobby. And this will follow up in the next meeting, as I said, with the logic puzzle, how many options are now. And so there's an excellent video from Anna in which, she explains in detail different ways in which you could solve the problem. Let me go and talk a little bit about some extra reading that you guys could use. So let me take a look at the solutions, and then I'll show you. So what do we want students to think? Like, how do we want to think about? Well, of course, these are tables, and the first way to solve these problems may be just brute force, just do all these tables. Of course, you cannot do all 120. Then the next step would be maybe drawing a tree representation about how it starts to look when you want to count them all exactly once. And trees are very powerful. So you would spend a lot of time in the meeting in part one dealing with trees. It's kind of the heart or the center. And then you would write these these expressions that involve either multiplication or addition. So here we have some examples like 5 plus 5 plus 5 plus 5, that's 20, just to fill the first two rows, and then you can continue. Or of multiplications, 5 times 4 times 3 times 2 times 1. No need to talk about factorial. And then you would talk a little bit about these called the time strips. And so this is kind of telling a movie, like scene 1, 5 options for Alan, scene 2, the second scene of the movie, 4 options for Kevin, because Alan, we already chose some occupation, so Alan cannot choose the same one. And then you keep telling this movie, and then Sandra really doesn't have any choice from what we did in the past. So when you multiply and reflect in this table, it's going to be 120 total final branches or field tables. And you can go back and forth, like this branch, which table would it represent? So you start matching these different representations. Maybe some students may have not done many counting problems at all, so it may be brand new, like a brand new mathematical adventure. So take that into account. It may be, even if they only do part A, it's still a lot of growth or a lot of mathematical ideas, new ideas for many students. So that's probably important to take into account. And then, okay, we have this challenge, which is adding a hobby. And you can see in the video how this 14,400 number is being computed. How can we do that? More than one way, it's important. Remember, in coaching, you have been doing these kind of things. So this is part 1, which is a pretty good part. Let me actually have a look and tell you a little bit about what I meant with the curriculum. So let me go take a look here. So I'll just open the curriculum and tell you a little bit about some. So in Canvas, we used to publish a lot of resources for you guys, and we're very happy, of course, that you're reading them and commenting. But so for Meeting 5, we have some thing called time strips for counting. Let's open that. Let's see how this looks. So this you can find on Canvas, or you can also find in the teaching resources, as I just did. Just open this. And the global teaching perspective of counting in this meeting, in this part of the meeting. Of course, there's many more things about counting, but this is a pretty, solid for choice of how to teach this for the first time, especially if students don't have any idea of how to represent these counting problems. So the first thing, let's say you have this problem about a food combo in which you can have 3 meals or two drinks. How many combos are there? So I don't want to go much into the math details of this particular problem, but more the general idea of the progression, the order of teaching, so to speak. The first part is brute force. So list all the combos, all the possibilities, and a lot of bad things can happen or good things, like interesting things. So a lot of chaos, like maybe you didn't list them all. Maybe there's too many. Maybe you count them twice. So you're not necessarily being systematic. Of course, as you're more systematic, you don't need to list them all, but just imagine that you have listed them all. This example is pretty easy because you have only 6 choices, but of course in the manual, in the activities, you have 120. So of course, brute force is not gonna work, but you always do it, even if you have just a few examples, just to check that students are understanding what they're supposed to be counting. Okay, so brute force is always a must, always. After brute force, you start connecting with a tree, and you're starting, okay, how can we categorize? Okay, what else is missing from this brute force? So you start kind of organizing all these ideas. So, okay, first I can choose water or lemonade, and then I can choose 3 options. So some students may think that this is 2 plus 3, just 5 combos, but it's actually 6 combos because you duplicate, right? Because you have 3 for the water, but also 3 for the world or the, this branch that you chose, lemonade. So you start making sense of how to represent this and how to count. It could be 3 plus 3, but it could just be also 2 times 3, right? Because it's 3 and another 3. So you start, playing around kind of back and forth between addition and multiplication and how to connect them. Spend a lot of time in trees, because that's where really students, for our brain, it's really where it sticks, the counting. And it's the most powerful representation, I would say, for these type of problems, because it's so flexible and it really connects to everything, right? It connects to the brute force, because if you already counted chicken water, you can look where it will be, okay? So I guess not chicken, but beans. I need to change this. But also you can connect to addition formulas or multiplication kind of quick. And the last representation, which is abstract, but not as abstract as just a formula or a numerical expression, is what we call a time strip, which is an abstract squash tree, right? It's like we squash kind of this tree and we still go linear, but we don't have to explicitly open all these branches, but kind of imagine that we open 2 in the first part and then 3 in the second part. So it just tells me a story that 2 times 3 is 6. So we actually have 6 combos. You want to see what they are? Look at the tree. Okay. You want to see more what they are? Look at the brute force. So you can go back. You can go back in these representations. You don't have to stay just in one of them. And then some reflection questions. Okay, so I just wanted to point out this excellent resource that we created, because it will give you very fundamental and deep understanding of what students are supposed to be doing mathematically in the meeting. So let's go back and maybe move on a little bit and talk about the next part of the meeting. So after the break, you'll play Othello. There's excellent videos that tell you how to teach. So let's just do a little bit about the breakdown. So first, so actually 20 minutes, sorry about this. As students will be playing the game, learn to play, participate in the tournament. And then the last 10 minutes or so, students will reflect on the best strategies that were used to play the game. It should be kind of quick, and you could do it at the very end, maybe with all tables together. It will depend on your LAs, or maybe a little bit in your table. Okay, so this is a very fun game, and you'll just need, of course, we'll give you all this during coaching and during the meeting, chessboard 8x8, and then these tokens that are 2-color tokens. I think we'll be using red and yellow, but otherwise you can use any other 2 colors. So it would just depend on your table. So I think that's it. I just want to make sure, or also make some publicity and the teaching manual. We have these type of questions. This is optional, of course, but you can try to think of these questions and how would you ask them. So if you're preparing with your commenter or even by yourself a little bit, you can at least list maybe one analyzing question that you would ask, one generalizing question, and maybe one justifying question. Because then the quality of the meeting, mathematically speaking, will be a little high if you come prepared with these questions. Final thing, it's to talk about the goals. And it's gonna be tricky because the enrichment goals, especially about the stereotypes, you don't want to say it from the beginning. You want students to discover stereotypes. So you don't go in these meetings very special. It's not, the idea is not to say, okay, we're gonna talk about stereotypes today and be careful and don't have stereotypes. That would be absolutely not productive approach to this meeting, because you're telling them what to do, and it's not going to be as powerful as them checking the stereotypes that others, right, detecting the stereotype from mentors or from students or from themselves. Oh, I wonder if a mathematician could be also a woman, or things like that. So it's very important to keep that in mind. Counting will be making sense of counting situations by giving example, the brute force that I was talking about, also using tree diagrams flexibly, using time strips, and finally, if you can get to this goal, it will really be really important, extend counting problems that we already solved to new problems that are a little more complicated. How about the enrichment? It's kind of in the middle of the meeting, of course, so we'll appreciate the relations, kind of cherish them, like maybe reflect for a minute or so that you have built with, of course, with mentors, but also with your students, and say something about it. So it's really a goal to kind of recognize that we have some relations, or you have some relations with your students now. So it's important to say that at some moment in the quarter, and this meeting may be a good time to do so. Empower mentors and students to be people that ask lots of questions and like challenges in a positive environment. So we'll go in for the challenges, especially for this part 3 in this choices problem. So of course, if you don't have time, that's totally fine. But again, if you have time, embrace this challenge and say, yeah, it gets more complicated, but let's have patience. So it's really important to kind of frame it not like counting is really hard and only few people can do it and it's for genius. No, not at all. It's kind of flipping the tortilla, really, and really embrace the challenge. And if you have trouble counting, it's totally fine. It's a challenge, of course, but embrace it, right? Don't be like, it's really hard and okay, would I get it wrong or would I get it right? More like adventure, more like exploration, like a scientific approach to that. So we really would like mentors to help students grow in that, right? In that we have high expectations for the students always. Resist damaging biases that we or others have towards certain groups of people, and learn about how we can recognize them or bring them to the front. So recognize them and have a mindset of resisting this bias, like it's not correct. I may commit it, of course, a lot, but kind of recognizing that. And then follow up, of course, apologizing to people that we may have hurt, even if the person is not in the meeting, just recognizing that, telling us totally how once you may, have some experience in which clearly there was a bias, and you would like to apologize to this person or group of people. Acknowledging with your own words, really important, of course, and really change our mindset. We don't expect to kill our bias. That's not the meeting it's all about, but recognize them, bring them to the front. kind of like a student may be afraid of talking about this, I guess the goal on this meeting is don't be afraid. Let's talk it out. We all have stereotypes or biases, and it may be a hard conversation for many people or groups of people. It may be uncomfortable, but it's okay. It's part of, a part of our curriculum in this cultural component. It's about don't run from things that are uncomfortable. It's fine. We're all together. So it adds a new dimension to just doing abstract math, right? So hope you have a lot of fun in this meeting, and have a lot of fun in Othello. Hopefully you can play it before the meeting a lot, not just in coaching, but maybe with friends. Of course, you can play it online. There's lots of portals or websites but if you can play like, in with a real board, with your parents or with sisters, etc., it may be actually quite enjoyable as well. Have a lot of fun and see you next week.